Good evening, mathematicians. Let's take a look at our final two shortcuts for proving triangles congruent, the angle-side angle and the angle-angle-side congruence theorems. So our essential question, what information is sufficient to determine whether two triangles are congruent, which is a great question for our entire unit on triangle congruence. Let's get started. All right, here's our angle-side angle congruence theorem. It states that if two angles and the included side of one triangle are congruent to two angles and the included sides of a second triangle, then the two triangles are congruent. So let's take a look at our two examples here. If angle A is congruent to angle D, as marked on the picture, and side AC is congruent to side DF, as marked on the picture, with our tick mark, single tick mark on each triangle. Then we have our second pair of angles, angle C congruent to angle F, as marked with the double arc marks. Then we conclude that triangle ABC is congruent to triangle DEF. Included side is the side that's between the two corresponding congruent angles. Next, we have the angle-angle side congruence theorem. It states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So in other words, if I have two angles congruent in each triangle, and a side that's not included, in other words, it's not between the two angles. So it's over here on this side and it's corresponding, or it could be on this side and it's corresponding. It's just not included between the two angles that are congruent. Then we can conclude that triangles ABC and DEF are congruent. All right, so take some time to copy down this proof. It's an angle-angle side congruence theorem. And you're given that angle A is congruent to angle D, angle C is congruent to angle F as marked on the picture, and a non-included side, which is BC, congruent to EF. So again, in your structure of a flowchart proof, all your givens are on the top row, and each given has its own box. Statements over reasons. And when your statements are part of your givens, then that's your reason. We happen to have three given statements, so all three boxes are on the top row. A strategy to keep track of all the parts that you need to use to prove triangles congruent. In this case, triangle ABC congruent to triangle DEF. Put letters out to the sides of each of the boxes that identify your parts. So we've got angle part, a second angle part, and then a side part. And in this case, it's a non-included side. And that's all you need to prove triangles congruent. And remember, all boxes have to have arrows pointing to your triangle congruence statement. And this is your final conclusion. It is the statement that we are trying to prove. So it's always your last statement in the entire proof. And our reason is the angle-angle side implies congruent triangles. All right, so let's take a look at example 1, where we want to identify congruent triangles. So let's answer this question. Can the triangles be proven congruent with the information that's given in the diagram? And if so, state the theorem you would use. So let's look at A. Where are the two triangles that we're trying to prove congruent? So let's take a moment to highlight. All right, so it looks like we have these two triangles that have tick marks on two sides. That means that these sides correspond and are congruent. Then we have angle arc marks on two angles, which means that they are, and it's the same number of arc marks, so that means that they correspond and are congruent. So the question is this enough information to conclude that these two triangles are congruent? So one thing to note is there are intersecting lines. Anytime you have intersecting lines, you always have vertical angles. and vertical angles are always going to be congruent. So now do we have enough information? And it looks like we do. So by the angle side congruence theorem, we can conclude these two triangles congruent. Now you try B and C on your own, so pause the video and then unpause to check your answers. All right, for option B, there is not enough information to prove the triangles are congruent because no sides are known to be congruent. We only have angles, and angles are not enough to conclude triangles are congruent. So here is a common error to note. You need at least one pair of congruent corresponding sides to prove two triangles are congruent. If you'll notice, all of our options have at least one pair of sides. So this is super important to note and add to your notes. You cannot just have angles, not enough information. And then part C, two pairs of angles and their included sides are congruent, so the triangles are congruent by the angle side angle congruence theorem. All right, so let's see. In this picture, can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So some things to think about are the lines that are parallel. So we have some lines that on opposite sides of the figure. So we have XY parallel to WZ because of our double arrows. And then XW is parallel to YZ because of the single arrows. And this YW or WY serves as a transversal. It's the diagonal of the figure, but it serves as a transversal. Anytime you have parallel lines cut by another line, that's called a transversal. So if you remember from Unit 3, that allows us to identify some special angles, like angle 1 and angle 3 would be considered alternate interior angles, so therefore they're congruent. We can also conclude that 4 and 2, because of the transversal of these two parallel lines, are alternate interior angles. So remember the strategies to help you identify your special angles, the alternate interior angles. It forms a Z, so 4 and 2. Or you could identify a Z going this direction, which would allow you to identify angles 1 and 3. So yes, by angle side angle implying congruent triangles, these two triangles, WXY and YZW, are congruent. All right, let's look at some more examples. Can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. So let's take a look at this first example. Can triangle EFG and triangle HDG be proven congruent? So we have GF with a tick mark and DG with a tick mark, so that means these two segments are congruent. So we have at least one pair of corresponding sides congruent, which means we have at least an option to prove these triangles congruent. We have to have at least one pair of sides, so check. And then we see right angle symbols for E and angle H, which helps us realize that these are right triangles. So we would be considering maybe the hypotenuse leg theorem. And then let's see, we have lines that are intersecting, so that means we have vertical angles. These are very popular, so make sure you look out for any lines intersecting because you'll always have some vertical angles. So it looks like we have enough information to conclude that these two triangles are congruent, and we actually will not be using the hypotenuse leg theorem. Instead, we'll be using the angle side, which implies congruent triangles. Now pause the video and you try example B and example C by yourself, and then unpause to check your answers. All right, so choice B has not enough information to conclude that the triangles are congruent. We only know the tick marks. We don't know if this is a right triangle. We don't have enough information. Part C looks like we have enough information because of the two triangles sharing the same side. we can conclude that by angle, side, angle, these triangles are congruent. All right, here's another construction. So please pause the video and try these constructions. This time you're copying a triangle using angle, side, angle. All right, there are two more examples that I want you to add to your notes. I did not provide you the fill-in page for example 2. So write this proof on the top of page 54 of your trimester 2 interactive notebook. And it's just going to be an example that we can reference and use as we're trying to understand proofs and trying to understand our shortcuts for proving triangles congruent. This is a great example for angle, side, angle. So take some time to copy this proof into your notes, keeping in mind the structure, what you're given. All the givens are up top. Anything you can glean from or take from the picture that doesn't have to be stated as a given, but something that you can look at the picture and conclude, such as vertical angles, are always angles that you can identify and mark in your picture as congruent and would be treated like a given, so it's in the top row. And then just remember to put your parts as you get them in your proofs. So we have sides as a given, and then the vertical angles we can use, that's a part, and then your other angle, which has the angle D is congruent to angle C, and that's because of lines being parallel. So anytime you have lines parallel, that means that you could possibly have the alternate interior angles or any other type of angles that we learned when we have lines parallel cut by transversals. And then also just remember that all of the boxes that have the labels for the parts have to have arrows pointing from them towards the final conclusion. In this case, it is triangle ABC is congruent to triangle DEF, and our reason is the angle, angle, side. And that's because we have an angle, and a non-included side that implies congruent triangles. All right, and then this is example 3 for an angle, angle, side congruence theorem proof. So get this one recorded at the bottom of your page 54 of your T2 interactive notebook, so you can use it and reference it as you're learning more about your proofs. Again, structure, givens. Here's another popular statement that can be made and is treated similar to the givens, and that is that HG is congruent to itself, GH. So that's this side here. Again, if two triangles are sharing the same side, it's always part of your proof as treated similar to the given. And our reason is the reflexive property of congruence. All right, so check everything else out, get it in your notes, and come with questions if you have them, anything that we can clarify in class together. All right, this concludes all of the possible shortcuts that we can use to prove triangles congruent. So let's ponder. We have the side, angle, side theorem. That was the first one. Then we learned about side, 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 and the hypotenuse leg that's part of a right triangle. And then this lesson, which addresses the angle, side, angle, and the angle, angle, side theorems. And just remember, there's that one theorem that we cannot use because it spells a bad word. So don't use that one. All these other ones we can use. So ponder this, and we'll have some practice problems to help us understand these theorems a little bit more in class tomorrow. Have a good evening.